All right, so 8-6, I do expect you to know the law of cosines formulas. So let's look at when we actually use law of cosines. Used when the law of sines cannot be used. In other words, when you do not have the side across from the angle measurement. So you usually have SAS. You have an included angle and two sides. You don't know the side that's across from the angle. So SSA, which is a bad word spelled backwards. Actually, you didn't have SSA because we didn't give that to you because that's the harder one. Well, you did have SSA, but we didn't give you the hard one. Let's put it that way. Or you could have had AAS, right? Those are the ones that you had with law of sines. But you always had either the ability to find or you had the angle across from the side that's associated with it. But look at what happens here. Law of cosines, here's your formulas. So there's 3 of them. We've got a squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. I just want you to look at just that one. So you don't get overwhelmed and go, oh my gosh, I have to memorize that. Because the law of sines is easy to memorize, isn't it? That's a piece of cake. This one looks like the Pythagorean theorem, but this one would be using if I was solving for side A or for angle A. Side A or angle A. We'll have 3 different ones, but you'll see a pattern to them. Notice that if I've got A by itself here, then I have the other 2 sides being squared and added over here, and then I subtract 2 times these being multiplied together and the cosine of that side that's by itself. Okay, so it looks like the Pythagorean theorem, but we have an adjustment to the Pythagorean theorem here. This really isn't quite the Pythagorean theorem, right? Because normally wouldn't it be c squared minus b squared? But you can take into account, oh, that minus is actually here. So then if I had b squared, what do you think comes over here? What would be here? A squared plus c squared. What else? Minus 2, these 2 multiplied together, AC times cosine of angle B, so big B. Right? And so these 2 go together. Once you know one, you know the other ones. And once you know one, I would really only memorize one, write it on your test, and then you can write the other ones as needed, can't you? Don't overwhelm yourself with memorization. I don't believe in it. But the only reason why I'm going to make you is because your calculus teachers expect you to know it. Your university courses will not give you a cheat sheet on these either. So then c squared would be what? Well, not c squared equals what? A squared plus b squared. So that looks like the Pythagorean theorem right there, right? Minus 2ab times cosine of c, right? And so then these go together. So don't get overwhelmed by your formulas. They're really not that difficult. There is a minus in both of them, or all 3 of them, I mean. So it has a definite pattern. Is everybody okay with that? If you want to see how it's derived, go on YouTube and look at the proof for the law of cosines. I'm sure you'll be fascinated by it. I'll bet none of you are going to do it. All right, so there are two different cases where these can be used. So case one, if you know the measure of two sides and the included angle. Wasn't that SAS? The other one that I didn't mention of when the law of sines cannot be used, the other one would be case two. You know the measure of all three sides. So that would be SSS. We did not have SSS in law of sines because you need one angle in order to do law of sines. It has to be across from one of the sides that you have been given. So let's look at some examples. Did I what? Did I? Oh, oh, thanks. I said I just didn't write it right. No, the measure of all three sides. Thank you. My hand does not write as fast as my brain. All right, so example one. Pay attention again to the directions. Are they asking you to solve the triangle or just find one thing? So example one, for triangle ABC, find little b, so you know you're finding side B, if the measure of angle B is equal to 48, A is equal to 7, and little c is equal to 4. You may or may not have a picture with this. So if you don't have a picture, you should always draw one. It doesn't matter what kind of triangle you draw, just draw a generic triangle. I'm going to label this ABC. I'm going to put in what they gave me. So I'm finding side B. Side B is across from angle B, so I'm going to label that as B. Angle B is 48, and I'm going to use degrees. Side A is across from angle A, so it is 7. And side C is across from angle C, and that is 4. Which case is this? Is it SAS or SSS? SAS. Do you see why I cannot use the law of sines? I have no side opposite the angle that they gave me. I have no way of finding these because these sides are not the same like they were in example 7 on practice 8-5, right? So we had to have another way to find this. So since I'm finding side B, I'm going to set up my formula. B squared equals what? I'm missing A, so A squared. I'm missing C, so C squared. This is always minus 2. These get multiplied together, AC, and then times it's the law of cosine, so cosine sounds reasonable, of what? Big B, same as this one here. So you've already practically memorized it by looking at the pattern, right? So let's plug in what we know. And for your sake, you might want to say, okay, this is C, so I'm going to put C equals, and this is A, so A equals, so that you don't have to think too much. So I'm going to use substitution parentheses, right? And so I'm plugging in for A, 7. Oh, I need to square this one. I'm plugging in for C, 4. And so then I get 7 and 4 here also. I need to find the cosine of, bless you, 48 degrees, right? So either look up on your table, here's 48 degrees. Cosine is your center column, so we've been used to using the first column, so don't make that mistake. So we've got 6691. So we're going to use our handy dandy calculator and get to know your calculator. The graphing calculators are fabulous because you can just put it in exactly as you see it and it's going to calculate it for you. If you have a less than graphing calculator, then you might have to use order of operations. So know your calculator, although these ones are what you're going to use in your test. So 7 squared plus 4 squared minus 2 times 7 times 4 times 0.6691. 6691. Is that what you're looking for? Did I put an extra 9 in there? Oopsie poops, that's going to mess everything up. 66910. How about that? So we have not our answer. Because what have I solved for? B squared. How do I get B? Take the square root of both sides, right? And we're not going to do plus or minus because B cannot be a negative value. So I'm going to take the square root. So you either put the full number in on the graphing calculators, you can do a fabulous little thing, or I can take the answer from above and just take the square root of it. Otherwise, I want you punching in the whole decimal that you got. So we're going to round to the tens place, so we get approximately 5 point what? 2 units. Because I don't know what feet, inches, I have no idea. So that answers the question. If you have a question that looks like this, don't make it into a word problem. Say, therefore B is. It's not really a word problem. All right, so let's look at example 2. Can I flip this? Nope. Good? Okay. So example 2. In the notes, my example, in the notes that are online, my example actually is a word problem. But we're running short on time, so I'm going to make it so it's not. But if it were a word problem, you'd do the four-step plan. So this time you have a triangle that looks like this. You have been given that this is 172 meters, this is 98 meters, and this is 150 meters, A, B, C. And you need to find x degrees. You need to find the measure of angle B. I don't have any of my angles. All I have are my 3 sides. Isn't this case 2? So if I'm finding angle B, do I want A squared equals, B squared equals, or C squared equals? B squared because of angle B. So I want that same formula we used on the last one. B squared equals, the 2 that are missing are A squared and C squared, so add them together, minus 2, multiply these together, AC, and then times the cosine of big B. So plug in what you know. We don't know cosine of B. That's the one thing that we don't know. Side B is 172. Make sure that you're doing the correct one. Technically meters. And then A would be 98. and C would be 150. And then the 98 goes here, and the 150 goes here again. So if you square 172, you get a lovely big number. 29,584 equals 98 squared is 9,604 plus 150 squared. 15 squared is 225. A 0 squared would be 2 zeros. So it's 22,500 minus 2 times 98 times 150. 29,400 times the cosine of b. Shouldn't we be trying to get the cosine of b by itself? So let's do some math. I'm going to add these together right there. So I've got 29,584 equals, we're going to add the 9604 to the 22,500, and I get 32,104 minus 29,400 cosine of b. All I did was add those two. I'm still solving for cosine of b. Look at it as in an x. Wouldn't you want to get this whole thing by itself? Shouldn't I subtract 32,104 from both sides? So 29,584 minus 32,104 should give us a negative, which it does. Negative 2,520 equals, this is now a negative 29,400 times the cosine of b. I'm solving for cosine of b. Isn't it being multiplied by negative 29,000? Don't we divide by negative 29,400 to both sides? So I'm going to flip this. Cosine of b is equal to, the negatives cancel, don't divide this out. We're just going to leave it as 2520 over 29,400. I really want b. If I don't know the angle, how do I solve? Inverse cosine, right? So cosine to the negative 1 of 2520, whoops, divided by 29,400. If you're using your table, you're going to figure out what that decimal equivalency is and then locate it in your chart. Okay? So the 4-digit decimal that's equivalent to this is 0.0857. That's what you'd be looking for in your chart, or you do the inverse cosine on your calculator. So 0.0857 on cosine is all the way down here. So 0.13560857, wouldn't it be in between these two? So your answer would be 85.5, right? So if I did that on my calculator, inverse cosine, did I get 85 point, doesn't it round to 1? So technically the measure of angle B is approximately equal to 85.1. If you're using your chart, you would have said 85.5. So we did one of case 1 and one of case 2. There is an additional solving of a full triangle online. For example, 3 of your notes. And we'll do another one tomorrow in class too.